Hi there, Miss Barber here. This lesson is titled Marginal Analysis in Business. We discuss several applications of derivatives to business in this lesson. In this study, we use extensively the following two basic models. That's profit is equal to revenue minus cost and is often written mathematically as capital P of X equals capital R of X minus capital C of X, and that revenue is equal to quantity times price. That is, if we defined lowercase p of x as the price demand function and x as quantity, then revenue R of x is equal to x times p of x. Be careful not to confuse capital P of x, which is profit, with lowercase p of x, which is often used to mean price demand function. In many situations, analysts are concerned with how revenue, cost, and/or profit are changing at a given production or sales level. We can use the derivative to find this instantaneous rate of change. We define marginal cost function. Let C of x be the total cost of producing x items. We define the marginal cost function as the derivative of the cost function C of x, denoted either C prime or MC. It is used to approximate the exact cost of producing the x plus 1st item. That is, if x is 100, then we use it to estimate the 101st item. The definition of marginal cost is readily extended to both the marginal revenue function and to the marginal profit function. That is, marginal revenue function we can write as MR, which is R prime of x if the total revenue is R of x, and the marginal profit function, which is equal to MP, which can be written as P prime of x if the total profit is P of x. Example 2.3.1. Find the marginal cost, marginal revenue, and marginal profit functions for a manufacturer that has modeled their cost as C of x equals 2,000 plus 10x minus 0.5x squared, and their price demand function as lowercase p of x equals 5 minus 0.05x. To find the marginal cost, MC, what we really need is just the derivative of the cost function. So the derivative of 2,000 is a constant, is 0. The derivative of 10x is 10, minus, and the derivative of 0.5 times x squared. Well, we bring the 2 down, so 0.5 times 2 would just be 1.0x. So that's the marginal cost. Now, in order to find the marginal revenue, we have to first get the revenue function. And so we know that the revenue function, R of x, is equal to the quantity x times the price demand function. So that'll be x times the price demand function is given as 5 minus 0.05x. So if we distribute that x, it'll be 5x minus 0.05x squared. Now we can take the derivative of that to get the marginal revenue. The marginal revenue, MR, is the derivative of the revenue function. So the derivative of 5 times x is just 5. The derivative of negative 0.05x squared, well, we need to do 0.05 times 2. So that'll be minus 0.1x to the 2 minus 1 is just x. And finally, we've got, let's see, marginal cost, marginal revenue, the marginal profit, which is P prime. We can also compute this, pretty straightforward, as the marginal revenue minus the marginal cost. The marginal revenue we just got was 5 minus 0.1x minus the marginal cost, which is 10 minus 1.0x. Perform the arithmetic and we get that the marginal profit is equal to 5 minus 10 is negative 5. Negative 0.1x minus negative 1.0x would actually be positive 0.9x. Example 2.3.2. Find the exact cost of producing the 101st item if the cost function model is C of x equals 1,500 plus 8x minus 0.02x squared. Compare the exact cost to the marginal cost of 101. The cost to produce the 101st is the total cost to produce 101 items minus the total cost to produce 100 items. That is, we need to compute the cost function at 101 and subtract the cost function at 100. So let's compute C at 101. That would be 1,500 plus 8 times 101 minus 0.02 times 101 squared. Use your calculator, compute the output, and you'll get accurate to 2 decimal places, 2103.98. Do the same thing for C at 100. That would be 1,500 minus 8 times 100 minus 0.02, 100 squared. Use your calculator, and the output is 2,100. So let's compute C at 101, which is 2,103.98, minus the C at 100, which is 2,100, and the difference gives us 3.98. Continuing with this problem, let's find the marginal cost, which means, so we got the exact, now we're ready for the marginal cost. That's the derivative of the cost function. The derivative of 1,500 is 0. The derivative of 8x is 8. The derivative of 0.02 times x squared, 0.02 bringing down the 2 and multiplying it together would be minus 0.04, and then x. Then we need to evaluate this at 100. So the cost, remember we do it one below for the next one up. 800 minus 0.04 times 100, and that's 4. So let's compare. The exact cost was $3.98. The marginal cost, the approximation, was $4. It's very close, but the marginal cost was much easier to calculate. Definitions. If X is the number of units of a product produced in some time interval, then the cost per unit for average cost is defined or written as C bar of X, and it is defined as the C of X divided by X. That is, take the cost function and divide it by X. The marginal average cost, denoted C bar prime of X, is the derivative of the average cost function. For the revenue per unit, the average revenue is R bar of X, and that is equal to R of X divided by X. That is the revenue function divided by X. The marginal revenue function is r bar prime of x, and it is the derivative, ddx, r bar of x, or the derivative of the average revenue function. And finally, the profit per unit. The average profit, denoted p bar of x, is defined as p of x over x. That is the profit function divided by x. The marginal average profit, denoted by p bar prime of x, is defined as the derivative ddx of the average profit function.